If I had 16x squared minus 18x, can I factor this using the box? No, because it doesn't have 3 terms. The box only works if you have 3 terms. But, oh, sorry, 6x, not 16. Listen to what I mean. Don't listen to what I say. How do we factor this? I can pull out a 6x. So I take out a 6x. If 6x comes out of there, what's left? X. And if 6x comes out of there, minus 3. Those are the factors. If I set this equal to 0, what are the roots? Well, if 6x equals 0, the only thing x could be is 0. So x equals 0 is one of them. And then we add the 3 over, and we get 3. So that graph hits the x-axis at 0 and 3. Okay, what if I had 4x minus 6 equals 0? Can I pull anything out? A 2. 2 times 2x minus 3 equals 0. Shh. Hey, I had a complaint about you two this morning. People have trouble paying attention when you're flapping your jaws. So, anyway, just be quiet. Go back to sleep. Okay, what are the roots here? How many roots do I have? Just one. How come? I only have one variable. So this does not affect the roots at all. It is a factor, but it doesn't affect the roots. If I set this one equal to 0, what do I get? I add 3. 2x equals 3. Divide by 2. X is 3/2. Does that make sense? Okay. I want to look up another one. Oops. Okay, what if I had 36a to the 4th minus 48a squared? What can I pull out? I could pull out a 6, a squared, but a 12 would actually be better. If I pulled out a 6, I would get 6a squared minus 8a squared, and then 8, and then I could also take out a 2. So the biggest one is a 12. If I pull out 12a squared, what's left? Not 6. 3a squared minus 4. Hey, shh. Shh. I'm going to find you a new seat. So those are the factors. If I wanted to find the roots, then I would set this one equal to 0, and the only answer would be x equals 0. And then I would set this one equal to 0, and I would add the 4 and divide by 3, and then take the square root. But we haven't done that yet. And this problem doesn't ask you to find the roots. It just says factor. Okay. What if I had x squared minus 5m minus 35? This one I need to use the box. So x squared minus 35. What's the next step? Multiply those together. Negative 35x squared. Now, this is negative, which tells me the roots are different. And the middle sign is negative, which tells me The bigger one gets the negative. What are the factors of 35? 1 and 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7. Will one of those give me a negative 5? No. So this one is prime. Okay, a prime number is a number that doesn't have any factors other than 1 in itself. So a prime quadratic is one that doesn't have any factors that we can find. Now, does that mean the graph misses the x-axis? Not necessarily. It either misses the x-axis or it hits it at a really terrible decimal number that goes on forever and never repeats. Okay. How about 5x to the fourth? Oops. 5x to the fourth minus 40x to the third plus 80x squared. Can I pull anything out? 5x squared. So I write down 5x squared, and if I take 5x squared out of that one, what's left? X squared. If I take it out of that one, minus 8x, and if I take it out of that one, plus 16. Now I use the box. X squared and 16. Multiply those together. 16x squared. This is positive, which tells me signs are the same. And this is negative, which tells me they're both negative, so minus and minus. Are there factors of 16 that add to be negative 8? Negative 4 and negative 4. So I put in negative 4x and negative 4x. What does the top row share? X. If I take an x out, what's left? X minus 4. And if I take an x out of here, I get minus 4. And then I just double check. Is negative 4 times negative 4 positive 16? Yes. So my factors are 5x squared times x minus 4 times x minus 4. And the answer in the book would probably be this. 5x squared times x minus 4 squared. Now, if you write them both out, that's totally fine, but the book will probably put them together and square them. Okay? Let's do... Oh, really? Hang on a second. Oh, never mind. That's good. That's good. What if I had 5x to the third minus 20x? Can I factor that? Pull out a 5x. 5x times, what's left? X squared minus 4. Now what? What? No, well, we're just factoring. We're not finding the roots. Does it factor further? It does. You have to remember the easiest form of factoring. This is adopts. It's a difference of perfect squares. In order to be a difference of perfect squares, what do we need to have? We have to have a subtraction. And we have to have something squared minus something squared. So in this case, I have x times x minus 2 times 2. And adopts always factors into conjugates. So this would be 5x times what? X minus 2 and x plus 2. Okay. What if I had 16a to the fourth minus 25b squared. Is that a DOPS? Yes. What are the factors going to be? 4a squared minus 5b and 4a squared plus 5b. Okay. What about 81x squared plus 121? That one won't work. How come? It's a plus. So this breaks the rules, and that's not possible. Okay? All right. What if we had... Oh, man, I need to find one that's not... Okay, what if I had 4x squared minus 56 equals negative 25x? What do I need to do there? I have to move everything to one side. Do I want to move everything to the left or to the right? Probably the left. Why do I not want to move them to the right? You'll end up with a negative 4x squared, and we want that leading coefficient to be positive. So how do I move this over here? Add it. 4x squared plus 25x minus 56 equals 0. Now I use the box. 4x squared minus 56. Multiply those together. And we can do this in our heads. What is 50 times 4? Well, 5 times 4 is 20. So 50 times 4 must be 200. So I want to know 4 times 56. But I'm going to split 56 into 50 plus 6. So 4 times 50 is 200. And 4 times 6 is 24. So it must be 224. So negative 224. And I want to use the factors of 224 to create a 25, but, oh, it's 24x squared. That has a negative sign, which means they're different. And this one is positive, which tells me the bigger one's positive. So plus, minus, and over here it will be minus, plus. 1 and 224. That doesn't work. Negative 2 and 1, 12. That doesn't work. I'm going to need somebody with the calculator. 3 and... Malia, what do you get? 224. Oh, yeah, it doesn't work. Never mind. Okay, 4. 4 and 66. 56. Yep, there you go. 5 doesn't work. 6 doesn't work. 7, 8. 8 and 28. Why isn't this working? 4, 25, and negative 50. Oh, 7. We skipped 7. 7 and 32. That's the one I want. So 32x is positive and 7x is negative. What does the top row share? 4x. If I pull out a 4x, I'm left with x plus 8. And then this would be minus 7. Okay. Is negative 7 times 8 negative 56? Yes. Okay. So we end up with x plus 8 equals 0. What would the root be? Negative 8. And I end up with 4x minus 7 equals 0. Add the 7, divide by 4, x equals 7/4. Okay, that is a review of every type of factoring we've done so far. And you guys know that the roots of a polynomial just tell you where the graph hits the x-axis. Okay? And so far, we have factored binomials, things that have 2 terms, and trinomials, things that have 3 terms, but we've never factored anything that has 4 terms. And that's the last thing you need to learn today before you do your assignment. So let's say I had x to the third minus 9x squared plus x minus 9. Now, this is a quadrinomial. It has 4 terms. And how many roots does it have? Has 3. And factoring quadrinomials is very complicated. In fact, I really don't know how to do it. From how I understand it, you have to look at the quadrinomial, and you have to figure out what type it is, and then according to its type, there are different methods of factoring. I only know how to factor one type, and the others, there must be a bunch of other ways to do it, and nobody teaches you how to do it because there are other ways to find the roots, and we rely on those. But every once in a while, that quadrinomial is created in a very special way, and we can factor it by what we call grouping. Okay, so if I were to randomly throw a quadrinomial up there, chances are we'll never know how to factor it. There are other ways to find the roots that are actually not too bad, so we don't learn it. But sometimes those quadrinomials are created in a special way where we can factor by grouping. So if I give you one of these, you can group it. You won't have to know any of the other methods. I don't even know the other methods. But grouping works this way. You put the polynomial in order to third power, second power, first power, constant. And then you look at the first 2 terms and the last 2 terms. What do the first 2 terms share? X squared. So I'm going to write x squared, and if I pull out an x squared, what's left? X minus 9. Okay? And what do the next 2 share? Nothing, but we're going to pull out a 1, and you'll see why in a minute. If they have nothing in common, pull out a 1. So I'm going to write plus 1. If I take a 1 out, what's left? X minus 9. Now, when you get to this step, make sure that this matches that. If it doesn't, then this is not factorable using grouping. And I believe every problem I give you will work this way. Okay? This is a very special case of quadrinomials where you group, and you pull out the greatest common factor, and then you have 2 binomials that match. Okay? Now, we look at it entirely. What do this and this have in common? They both have an x minus 9. So I'm going to grab this x minus 9, and I'm going to pull it out. X minus 9. If I take this away, what's left? X squared. And if I take this away, what's left? Plus 1. Now, do you see why I needed that 1? And those are the factors. X minus 9 and x squared plus 1. Does x squared plus 1 factor again? Can I factor this? No, because is it adopts? Nope, because it has an addition sign. If it was x squared minus 1, then I could factor it, but it's not. Okay. 2x to the third minus 27 minus 18x plus 3x squared. What should I do first? put everything in order. Okay, in order to group, everything needs to be in order. 2x to the third plus 3x squared minus 18x minus 27. I group the first two. What do they have in common? X squared. What's left? 2x plus 3. I group the second set. This one's a little bit tricky. I have to pull out negative 9. Right? How do I know I need to pull out a negative? Well, they both have a negative, and in fact, that won't always be the case. But if I pull out 9, what's left? Negative 2x minus 3. Does that match up? No. I need this and this to match. So I'm going to grab that negative and pull it out. Now it matches. Okay. Now what do this and this have in common? 2x plus 3. So I'm going to pull out the 2x plus 3. And if I take this away and this away, what's left? X squared minus 9. Will that factor any further? Yes, that is adopts. So 2x plus 3 and x minus 3 and x plus 3. And then I'm done. Okay. Let's do number 10. 2a squared 2a squared plus 8ab minus 3a minus 12b. And these actually are in order. You'll see in a little bit. Let's group. What can I take out of that group? 2a. So 2a times what's left? A plus 4b. And then what can I take out of that group? Negative 3. And what's left? A plus 4b. So it turned out they were in the right order, which kind of seems weird, but that's how it works out. Now I pull this out and this out. A plus 4b times 2a minus 3. Can I factor any of those any further? Nope. They don't go any further. Okay. Do you guys have the hang of that? Do you need to see another one? One more? Okay. Let's see if I can find a hard one. 4x to the third minus 7x squared plus 28 equals 16x. What should I do here? I need to subtract the 16 over. 4x to the third minus 7x squared minus 16x plus 28 equals 0. Now I group. What does that group have in common? X squared. What's left? 4x minus 7. Oh, this is a good one. I'm glad we did this. What do those have in common? 4. So I'm going to pull out a 4. And what's left? Negative 4x plus 7. That didn't work. So what should I do? I should pull out a negative 4. So do both of these have a negative? Well, kind of. The first one has one negative and the second one has 2. So how do you know if you need to pull out a negative when they're both not negative? Well, it all comes down to this must equal that. And when I factored it this way, it didn't work. So now I'm going to pull a negative out, make this 4 a negative, and this will be positive, and this will be negative, and now it matches. So pull this out and pull this out, and I get 4x minus 7 times x squared minus 4. And this one is adopts. So 4x minus 7 times x minus 2 times x plus 2. Okay? All right. Let's do 3 through 31 odd. So 2.8, 3 through 31 odd. Okay, good luck.